Hello, this is Dr. Hanaa Assil, and this is a video talking about the most recent past paper that was done for AS chemistry at Excel. So this is the Pearson at Excel International AS, and this was the paper that was done most recently in October 2021. So let us discuss the questions, and as we go along, we can review the points that each question discusses. So this first question, of course, you remember that they are made up of two sections. The first section is multiple choice questions, and you're supposed to put an X in the boxes. So the first question says the maximum permitted concentration of sulfur in diesel fuel is 10 milligrams of sulfur in 1 kilogram of diesel fuel. What is the concentration of sulfur in parts per million? Now he's asking you to calculate the parts per million of sulfur. You should remember that to calculate the parts per million of sulfur, this is how we calculate it. We say the mass of whatever we're talking about in grams over the total mass also in grams times 10 to the power 6. Now, he says I have 10 milligrams of sulfur in 1 kilogram of diesel fuel. So I have to convert all of this into grams. So I have 10 times 10 to the minus 3, that is the 10 milligrams, over 1,000, that is the 1 kilogram of fuel, times 10 to the power 6. And if you do that, the answer comes out to be 10. And that means that the concentration in parts per million is 10. So you put an X in the box next to C. Okay? Now, the next part of the same question says 3.2 kilogram of this diesel fuel is burned in air. What is the maximum volume of sulfur dioxide that can be produced? Now, in the previous question, he said we have 10 milligram in 1 kilogram. Now he's saying I have 3.2 kilograms. So you should realize that 1 kilogram has 10 milligrams. So the 3.2 will have how much? So the mass of the sulfur is the 3.2 times 10. I want to change that to grams. So I multiply by 10 to the minus 3. So this comes out to be 0.032 grams. Now, number of moles is mass over molecular mass, and he wants the volume of this. So we have the 32 times 10 to the minus. So the mass over molecular mass will give me the number of moles, because I need the number of moles of sulfur dioxide and sulfur in order to get the volume of sulfur dioxide. So in order to get the volume of sulfur dioxide, I have to get the number of moles of sulfur first. Now, we said the mass of sulfur is 0.032 grams. The number of moles would be the mass over the molecular mass, 0.032 grams. That is the same as 32 times 10 to the minus 3. Now, that is divided by the molecular mass of sulfur. So that's 32 at the bottom is the molecular mass of sulfur. So that means that I have 1 times 10 to the minus 3 moles of sulfur. Now, you should realize that if I write the equation sulfur plus oxygen to give sulfur dioxide, the number of moles of sulfur is the same as the number of moles of sulfur dioxide from the comparison in the equation. So in order to get the volume of sulfur dioxide, you should remember that number of moles is volume over 24. So the volume is number of moles times 24. The number of moles that we got is 1 times 10 minus 3 times 24. That means that the volume is 0.024 decimeter cubed. Do we remember these equations? Well, we should remember these equations in order to be able to calculate. Now, the next question in this exam was which equation represents the second ionization energy of chlorine? remember, ionization energy was the energy needed to remove 1 mole of electrons from 1 mole of atoms of the substance in its gaseous state. Now, the second ionization energy is the removal of an electron from something that has already lost an electron. So those first two equations, A and B, are wrong. He's saying Cl minus plus electron. No, ionization energy is Cl going to Cl plus, that's first ionization energy, and then Cl plus going to Cl2 plus, that is my second ionization energy. You should realize that D is the equation for the second ionization energy of chlorine. Remember, chlorine starts as a gas. Now, if it changes into Cl plus, and that equation in C should not have all of these 2's, and if I remove these 2's, it is still the equation for the first ionization energy, not the second. Now, D is the equation for the second ionization. The third question was about mass spectrometry, and he has the diagram for the mass spectrometer. And he's asking which process occurs in R. Remember that what happens in this instrument is, at the very beginning of the instrument, I put in something that vaporizes our heater that vaporizes the substance. So that first black square at the beginning of the diagram is what vaporizes, is the heater that vaporizes. So that what enters the instrument at R is the vaporized substance. Now, when it goes to R, what happens to it? R is where the vaporized sample is bombarded by a beam of high energy electrons. So remember that at R, we have the vaporized substance bombarded by a beam of high energy electrons. Now, when we do that, we knock out an electron from each atom. So what happens in R is actually the fact that electrons are removed and positive ions are formed. So this is where we have ionization of the molecule now, or the atom. At the next part in T, where is T? Okay, if we say what is S, you should realize that in R we have ionization. In S, this is really electrodes, charged electrodes that help to accelerate the ions. So at S, we have acceleration. Now, he's asking about T. T, you should know, is a magnet. Now, what happens in the magnet or in the magnetic field is deflection. So at R, there is ionization. At S, acceleration. And at T, deflection. Now, deflection, how do they deflect? They deflect, we're trying to separate the different ions by the deflection. This is because as the mass becomes smaller, it deflects more. If the mass is heavier, it deflects less. So, which of these is correct? The ions with the greater mass have a smaller deflection. This is what happens at T. Okay, question 4 says a mass of 0.23 grams of sodium was added to 350 centimeter cubed of water to form hydrogen and a solution of sodium hydroxide. And the first question is, what is the concentration of sodium hydroxide? Now, in order to get the concentration of sodium hydroxide, I need number of moles. In order to get number of moles of sodium hydroxide, I need to get number of moles of whatever he is giving me as information. So he's giving me information about what? About sodium. I will use that to get the number of moles of sodium. Now, which equation do we use? Number of moles is mass over molecular mass because he gives me the mass of sodium. So 0.23, that's the mass of sodium, over the molecular mass or the atomic mass of sodium, which is 23. So that means I have 0.01 mole of sodium. Now I look at the equation. What is the relationship between Na and NaOH? 1 mole of sodium will give 1 mole of sodium hydroxide, and that means that the number of moles of sodium is the same as the number of moles of sodium hydroxide, and that means that in order to get concentration of sodium hydroxide, you should remember concentration is number of moles over volume, 0.01 over the volume, but he gives me the volume as 350 centimeter cubed. We do not use it as centimeter cubed. We have to divide it by 1,000 first in order to change it to decimeter cubed, and that gives me a concentration of 0.029. So that is my answer. Do we remember all of this? Please use this to remind yourself of all the different topics we're supposed to know. Now, what is the maximum volume of hydrogen which could be formed? So he gave me information about sodium. In the first question, he asked about sodium hydroxide. Now he's asking about hydrogen. Again, in order to get the volume of hydrogen, I need number of moles. Now, number of moles, I'm going to relate it to the number of moles of sodium. When we calculated here, the number of moles of sodium was what? Was 0.01 mole. Now, looking at the equation says the number of moles of hydrogen are half compared to sodium. That means number of moles of hydrogen will be the 0.01 over 2. That means 0.005 moles of hydrogen. Now he's asking about what? Volume. Volume is number of moles times 24. This is how we get number of moles of a gas. So it's the volume of a gas. Volume of a gas is number of moles times 24. So it's 0.005 times 24. And that means that I have 0.12 decimeter cubed. But obviously the answers, he's asking about the answer in centimeter cubed. That means I have to multiply that 0.12 by 1,000. So that means that my answer is 120. Okay, the next question says, what is the ionic equation for the reaction between sodium hydroxide and sulfuric acid? So sodium hydroxide was neutralized with sulfuric acid, and he's telling me to write the ionic equation. You have to remember how we write ionic equations. We said we write the equation first, the normal equation. Sodium hydroxide plus sulfuric acid would give what? Well, you should know sodium sulfate plus water. This is acid plus base to give salt plus water. We balance, so we need these two NaOH and two H2O for balance. So this is the balanced symbol equation. Now, how do we convert it into an ionic equation? Remember that we ionize everything that is aqueous. If something is solid or liquid or gas, we don't ionize it. So sodium hydroxide is a solution. It should be ionized. Sulfuric acid is a solution. Sodium sulfate would be a solution. You should remember that sodium compounds are all soluble in water. And H2O is a liquid. So H2O will not be ionized. So we're going to ionize. Ionize means I'm going to break each of them. The first one is positive. The second one is negative. The number of positives and negatives is the same as the valence. So the Na is Na plus, but I have two of them. The OH is OH minus. I have two of them. H plus, and I have two of them. Sulfate 2 minus, because the valency of sulfate is 2. And after the arrow, we have 2 of Na plus and 1 of sulfate ions. The water is a liquid. We do not do anything to it. It just comes down as it is. Then we look on both sides of the arrow and we cancel whatever is the same on both sides of the arrow. So what is the same here? Na plus and Na plus. SO4 2 minus and SO4 2 minus. What am I left with? I'm left with the hydroxide plus H plus to give water. But notice that this is 2, 2, 2. When there is 2, 2, 2, they cancel each other. So actually, that final equation is your ionic equation. Now, it is similar to which one? That's my first choice. Okay? Okay. The next question says sodium hydroxide was added to magnesium sulfate, and he gives me the equation, and he's asking what is the atom economy for production of magnesium hydroxide. Now, again, how do we calculate atom economy? You should remember that atom economy is the molecular mass of the substance we're talking about. So he wants atom economy of what? Of magnesium hydroxide. So atom economy will be molecular mass of magnesium hydroxide divided by the total molecular mass of all the products. That means everything after the atom. So the molecular mass of magnesium hydroxide, you know how to calculate molecular mass. It's the atomic mass of each of them times how many we have. So we have 1 magnesium, 2 oxygens, 2 hydrogens, over the total molecular mass of all the products. So that means you want the molecular mass of magnesium hydroxide plus the molecular mass of sodium sulfate. Doing this, you get that the atom economy is 29.1%. Okay, remember all of that? Okay, this next question says, in which series are the ions in order of decreasing ionic radius? Decreasing ionic radius. Now let's look at the periodic table. That first question says aluminium, magnesium, sodium. Where is aluminium, magnesium, sodium? Now, which of these is bigger as an ionic radius, aluminium or sodium? You should remember that as we go across a period from left to right, the atoms become smaller and the ions also become smaller. So actually, aluminium is the smaller one, not the bigger one. He wants decreasing ionic radius. So that's not my answer. Okay, let's look at B. B says lithium, sodium, potassium. Where is lithium, sodium, potassium? Oh, sorry. Okay, let's see. Here, lithium, sodium, potassium. So lithium, sodium, potassium is going down a group, and you should remember that going down the group, the atom becomes bigger actually, and also the ion would become bigger because we're having more and more shells. So this is the decreasing. Lithium is less than, okay, sodium less than potassium. So actually, this is going in increasing ionic radius, not decreasing. Okay, number C, we're looking at N and O and F. So what is happening to N and O and F? These are also becoming less. We said as we go from left to right in any period, the atomic radius becomes smaller and the ionic radius becomes smaller. So this is actually my answer. If I'm looking at O, S, and SE, no, they're becoming bigger, not decreasing. So my answer is N, O, and F. Okay. A stable ion contains 18 electrons, in which block is M3 plus. Now, you should realize that if I look at the periodic table, I have the ion has 18 electrons. That means after removing 3 electrons, it became 18. That means it had how many at the beginning? He wants element M, not M3 plus. So if M3 plus contains 18 electrons, that means M originally had 21 electrons. Now, which element has 21 electrons? That's scandium. So scandium is in which block? Remember, if it is a transition metals, the transition metals are called a D block, because if you write its electronic configuration, they will always end up in D something. Okay, question 7 says, he has a compound called ammonium iron 2 sulfate, and it is used as a source of iron 2. What is the relative formula mass of this salt? You know that to get the relative formula mass is the same as molecular mass, is the same as mass of 1 mole. All of them are the same. You just add up all the masses, the atomic masses of all the atoms. So I have Nitrogen is 14. How many nitrogens? Times 2. Plus hydrogen is 1. How many hydrogens do I have? Times 8. Plus iron is 55.8. Now how many do I have? I have only 1. Sulfur is 32.1. I have 2 of them. Oxygen is 16. I have 8 of them. And I still have the 6 water. Remember, if we're doing MR of that compound, you also add up the 6 water. So I have 12 hydrogens times 1 and 6 oxygens times 16. So the total of that is 392. So that is the relative formula mass of the salt as a whole. Now, the next question says ammonium sulfate is used in preparation of the double salt. What types of bonds are present in ammonium sulfate? Okay, let's write ammonium sulfate. Ammonium is ammonia that has donated 2 electrons to an H plus ion. So it has a dative bond with one of the hydrogens. But it is sharing 3 pairs of electrons with 3 other hydrogens. So it has covalent bond. And at the same time, if I'm talking about ammonium sulfate, so ammonium is positive, sulfate is 2 negatives, that is an ionic bond. So the bonds that I have are ionic, covalent, and dative covalent. Okay, now he's saying what is the total number of ions present in 0.1 mole of double salt? We said total number of something, atoms or ions or molecules. You have to multiply the number of moles by Avogadro's constant. So if I have 0.1 mole of this, how many total number of ions? Well, let's see. 1 mole has how many ions? It has 2 ammonium, 1 Fe2 plus, and 2 sulfate ions. So these are the ions from 1 mole. That means 2, 3, 4, 5. I have a total of 5 ions. And that means my number of ions would be the number of moles times Avogadro's number times 5, because each mole will give me 5 moles of ions. So you multiply the Avogadro's number by 5, and that gives you 3.01 times 10 to the 23. Do we understand that? Okay, in which series are the elements in order of increasing melting temperatures? Well, let's take a look at the periodic table again. We said if I'm looking at the first one, iodine, bromine, chlorine, fluorine. So he's going up group 7. Up group 7, what happens to the melting point? You should realize that actually iodine has higher melting point than fluorine, because as we go down group 7, it's gas, gas, liquid, solid. So iodine has higher melting point. So actually when I'm going up, it's not increasing, it's decreasing. So that's not my answer. Okay, lithium, beryllium, boron, carbon. Where are these? These are here. Now, as I go, lithium, beryllium, boron, carbon, what is going on with the melting temperatures? Well, you should realize that lithium, beryllium, boron, if we say they are metals, they are increasing in number of electrons, delocalized electrons, and that means their melting point would increase from lithium to beryllium to boron. And we said once we get to carbon, carbon has a giant covalent structure like diamond or graphite. So actually carbon has the highest of these 4. So actually that's my answer. Let's look at the others. Lithium, sodium, potassium, rubidium. We should remember as I go down group 1, what is happening to the melting point? The melting point decreases, not increases. Remember, lithium has the higher melting point in group 1. Now, silicon, phosphorus, sulfur, chlorine, as we go from silicon, you should realize that silicon is actually giant like carbon. So that's a very high melting point. And then phosphorus, sulfur, and chlorine are molecular, simple, covalent structures. So actually, the melting point here is decreasing, not increasing. So my answer was B. Okay? Okay. Which row gives the correct polarities of SF bond and SF6 molecule? Okay, SF bond, a bond between S and F, will that be polar or non-polar? Well, we should realize that when I look at the periodic table, fluorine is the most electronegative, followed by oxygen and chlorine, followed by nitrogen. We do not regard sulfur as electronegative. So actually, if I have a bond between S and F, the F is much more electronegative, so it will pull the electrons towards it, so that bond would be polar. So the bond of SF is polar, so my answer is A or B. But once I look at the whole molecule that has 6 SF bonds, each bond is counteracted by another polar bond in opposite direction. So actually, all of these cancel each other. So each SF bond is polar, but once you look at the molecule as a whole, they cancel. The polarities cancel each other. So the whole molecule as a whole is non-polar. Okay? Now, methane reacts with excess chlorine in UV light. So this is a question about substitution reactions in alkanes, and you should realize that substitution reactions in alkanes are free radical substitution reactions. Free radical substitution reactions means in presence of UV light, the first step, which we call initiation step, is a breakdown of the bond between Cl and Cl in what we call homolytic fashion or homolytic fission. So homolytic fission means that bond between the Cl and Cl will break up. One of each electron will go to each atom, and that is represented by a half arrow, an arrow with half a head, not a total head. So my answer here is B. So that would be my first step that happens, and that is the initiation step. Now, which of these molecules could not be formed in a termination step? Remember that after the initiation step, there was something called propagation step. And then after the propagation step, there was a termination step. And the termination step is one in which two free radicals join together to form something that is not a free radical, so it ends the process. Now, what are the termination steps that could happen? I could have two free radicals of methyl, and that gives C2H6, or two chlorine free radicals, and that gives Cl2, or one methyl and one chlorine, and that gives CH3Cl. Or if we had excess chlorine and we had two of the hydrogens replaced by chlorine, we could end up with a molecule that has two chlorines, CH2Cl2. Which of these could not be formed in a termination step? Termination step would never give HCl. The HCl is formed in the propagation step, not in the termination step. Okay, the next question is saying what is the skeletal formula of E2-chlorobutene? Remember that this would be 2-chlorobutene. 2-chlorobutene. So but has 4 carbons. 2-ene means double bond is in the middle, and 2-chloro means the chlorine is on one of the carbons in the middle. Okay, when we decide if something is an E or a Z, we look on both sides of the double bond, and we look at the priorities of each of them. So on the carbon on the left, the carbon has higher priority than the hydrogen. Carbon mass 12, hydrogen mass 1. So the one with the higher priority is down. Now, if I look on the other carbon on the other end of the double bond, the chlorine has a mass of 35.5. The carbon has a mass of 12. So the chlorine has higher priority. Now, when one of them, the higher priority is down, the other one, the higher priority is up, that is a trans, and trans is E. And that means if I draw it in a skeletal form, it will look like which of these? It will look like the one in A. You remember how to draw skeletal diagrams where carbons, a line indicates a bond between two carbons, and then you can find out how many hydrogens depending on the fact that each carbon has a total of 4 bonds. Okay, this is the other question, that part. What is the total number of sigma bonds in Z2-chlorobutene? So let's draw Z2-chlorobutene. This is what we have. Now he wants the total number of sigma bonds. Which of these are sigma bonds? Remember that any single covalent bond is a sigma bond. A double covalent bond is 1 sigma and 1 pi. So we're counting the number of sigmas. Now, where are the number of sigmas? Each single bond is a sigma, and the double bond, one of them is a sigma. So if you count all the number of these red bonds, they come up to be a total of 11 sigma. Do we understand how to do that? Okay, the next part, section B, is a part where you have short answers. So the first question says, complete the electronic configurations of the atoms of beryllium and calcium using the SPD notation. So beryllium, the first thing I do is look at the periodic table to find out how many electrons beryllium has. If I look at the periodic table, the number of electrons, of course, is the smaller number, the atomic number. So beryllium has a total of 4 electrons. Now, if I put 2 in the 1s, then the other will have 2 in the 2s. So that is the electronic configuration of beryllium. Now, calcium, I look at the periodic table and I find that calcium has 20 electrons. And remember, how do we distribute them? 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 6, 4s, 2. That is the distribution of electrons. If I have any more, I put them into the 3d, which takes up to 10. If I have any more, I put them into the 4p and so on. Okay, and then he is asking for the dot and cross of beryllium chloride in the gaseous state. Now, you should realize that beryllium is in group 2, so group 2 should be a metal, but actually he's telling me that the beryllium chloride is molecular. The word molecular means it is covalent, and that means I must have sharing. So to draw the dot and cross, we share a pair of electrons between the Be and each chlorine. The Be has 2 electrons, each chlorine needs 1. Remember that beryllium is one of the elements that do not obey the octet rule. It does not have a total of 8 electrons around it. So this is how it is written. Now he's saying in the solid state, this is how it looks like. The diagram uses lines and arrows to represent the 2 different types of covalent bonds. Remember that if you have an arrow, what does the arrow mean? The arrow means that is a dative covalent bond in which the electrons are given by one of the atoms, while um, um, normal covalent bond is written as a line, so the line indicates sharing a pair of electrons, each coming from one of the atoms. So when you have the line, that means I have covalent bond, and that means that the 2 electrons are coming from both atoms. If I have an arrow, that means both electrons that are used to make the bond are donated by one of the atoms, and that is because the chlorine has extra lone pair of electrons. Now he's saying the chlorine beryllium chlorine bond is different in both of them. Now let us take a look at the first one. Is this was the dot and cross that we drew, and that means we have an atom with 2 lone pair of electrons that are being shared, and the central atom does not have any unpaired electrons, so that means that the molecule is linear, and that means that the bond angle is 180. While the other one had the beryllium bonded to 4 bonds, the central atom does not have any lone pair of electrons, So that means that this molecule is tetrahedral, and that means that the bond angle is 109.5. Do you remember bond angles and geometry and things like that? Okay. He says anhydrous calcium chloride is ionic. Now draw a dot and cross for calcium chloride. So we're trying to draw a dot and cross of something that's ionic. Remember that we said calcium is in group 2. It has 2 electrons, so it's going to lose them and become 2+. But each chlorine has 7. It needs only 1, so we need 2 chlorines to take the 2 electrons that were donated by the calcium. And each chlorine, once it takes one of the electrons from calcium, it now has an extra negative charge. Do not forget to write the charges. Calcium now has 2+, and each chlorine has one negative charge. Now, explain why gaseous beryllium chloride and calcium chloride have different types of bonding. Why doesn't calcium chloride do the same covalent bond like beryllium? You should realize that if we look at where is beryllium and where is calcium, you should realize that calcium is a more reactive metal. That means it tends to lose electrons more than beryllium. At the same time, if I'm comparing them with chlorine, then you should realize that the difference in electronegativity between calcium and chlorine is much bigger than the difference in electronegativity between beryllium and chlorine. So that means that the bond between beryllium and chlorine will have more covalent character, and that also is because the beryllium is a smaller atom than the calcium. So beryllium is a smaller atom, less shells, higher charge density, so it is more polarizing. So the beryllium-chlorine bond is more covalent than the calcium. The difference in electroactivity between calcium and chlorine is more than that between beryllium and chlorine, so the calcium-chlorine bond is more ionic, or has more ionic character. Now, this is another kind of questions where he gives the relative abundance for each isotope and he tells you calculate the relative atomic mass. You remember that to calculate the relative atomic mass, I take the mass number times the abundance, plus the mass number of the other one times the abundance, plus the mass number of the third one times its abundance. And all of these are over 100 because these relative abundances are in percentages. Now, when the answer comes out to be 28.1095, please check back with the question. The question says it wants the answer to 2 decimal places. You cannot leave the answer like that. You have to change it into 2 decimal places. Round up the numbers correctly. This is 28.11, not 28.10. Okay? So just a reason why there is a small peak in the mass spectrum of silicon at m over z14. You should realize that the m over z of silicon is now 28 point something. Why would I get a peak at 14? That means that the atom must have lost 2 electrons. So now I have a charge of 2+, and that means the m over e is 28 over 2, and that's why I have a peak at 14. Remember that a peak at half the molecular mass is due to an atom that lost 2 electrons, and that means I have a charge of 2+. So my E is 2. Okay, this is a very simple question. He's asking you what's the number of protons and number of neutrons, and you should realize that the number of protons is the same as the atomic number. So when you look at silicon, atomic number is 14. So the number of protons for all of them is 14. Now, how do we get the number of neutrons? It is the mass number minus the atomic number. For each of them, the big number minus 14. So 28 minus 14, 29 minus 14, 30 minus 14. These are the number of neutrons. Okay, this is a question about silicon dioxide, and you should remember that silicon dioxide has a giant three-dimensional structure that is similar to that of diamond. Now, the crystalline silicon dioxide is used on the surface of semiconductor devices to provide heat resistance and electrical insulation. So he's telling me this compound is heat resistant. Heat resistant means its melting point is very, very high. If I heat it, it doesn't melt. Electrically insulating means it does not conduct electricity. So he's saying, explain how the structure and the bonding make it useful so that it is heat resistant and electrically insulating. So if we say the structure and the bonding, why is it heat resistant? Why does it have high melting point? This is because it has strong covalent bonds in the giant structure that need a lot of energy to be broken. Now, why is it that it is an electrical insulator? It doesn't conduct electricity since it has no free moving electrons, just as we said for diamond. Okay, this question says I am trying to get calcium silicate. I want the empirical formula of calcium silicate, and he says I have a sample of calcium silicate that has 12 grams calcium, 8.43 grams silicon, and 14.47 grams of oxygen. Again, remember, how do we calculate empirical formula? Okay, we said we write the masses or percentages. Remember that he could either tell me calcium is 12 grams or calcium is 12%. I still do the same thing. So calcium is 12, silicon is 8.43, oxygen is 14.47. What do we do in the first step? Divide by the atomic mass of each one. So calcium we divide by 40.1, silicon we divide by 28.1, oxygen we divide by 16. I end up with these three numbers. Now the next step is divide by the smallest. So if I have 0.299, 0.3, and 0.9, I divide each of them by 0.299. I get a ratio of 1 to 1 to 3, and that means my empirical formula is CaSiO3. Please do not stop at the ratios. Don't get the ratios 1 to 1 to 3 and that's it, and you move on to the next question. He's asking for empirical formula. The empirical formula is CaSiO3. Then he's saying carbon dioxide is a gas. A fizzy drink is canned at 5 degrees Celsius, 1.3 times 10 to the 5 Pascal, and contains 3 grams of carbon dioxide, and he says calculate the volume. Again, when he gives you a certain temperature and a certain pressure, that means we have to use the ideal gas law, which is PV equals nRT. So we're trying to get V, so V is nRT over P. Now, what is the number of moles? Remember that if he gives me 3 grams, then the number of moles is 3 over 44. So N is number of moles, that is mass over molecular mass, so that is 3 over 44. Now, R is 8.31. He usually gives it to you. If he doesn't, you should know it's 8.31 plus the temperature. Now, the temperature has to be in degree Kelvin. Now, if he says it's 5 degrees Celsius, I have to add 273 to change it to Kelvin. The pressure is in Pascal, so it is the 1.3 times 10 to the 5 Pascal. That gives me a volume. Whatever volume comes out from that equation is in meter cubed. The equation gives you the volume in meter cubed. He is asking for the volume in centimeter cubed. You should realize that to change from meter cubed to centimeter cubed, I multiply by 10 to the 6. So that comes out to be 1210 centimeter cubed. Okay. Now, aluminium is an abundant metal. The first 4 ionization energies of aluminium are shown. So he's giving you first, second, third, and fourth ionization energies of aluminium. And he says, explain how this information shows that aluminium is in group 3. You should realize that we said group 3 means it has 3 electrons in its outermost shell. So when we do the first ionization energy, well, we have a certain amount. Second ionization energy, we have a certain amount. Third ionization energy, we have, and then when we go to the fourth, you find that there is a huge rise in the amount of energy needed to remove that fourth electron. So that means that the 3 electrons were in the same shell, in the outer shell, and then once we have removed them, we're trying to remove, for the fourth ionization energy, we're trying to move an electron. that is in an inner shell nearer to the nucleus, more strongly attracted to the nucleus, so it needs a much higher amount of energy to remove it. So when you find that there is a huge increase in the ionization energy between the third and the fourth, that means the atom is in group 3. Okay? Then he says the graph shows the first ionization energies for elements in period 3: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Explain the general increase. Now, why does ionization energy in general increase from sodium to argon? You should know that as we go from left to right in a periodic table, we are first of all in the same number of shells. So it is the same amount of shielding. But as we go from left to right, the number of positive electrons in the nucleus increases, and that means more positive charge is attracting these certain number of shells, and that means that the atom becomes smaller and smaller from left to right, and that means we will need more and more energy to remove that outermost electron. Now, explain why the first ionization of aluminium is less than magnesium. So if you look at, it's much easier to write the electron distribution so that you can be able to explain why aluminium is less than magnesium. So once you write the electron distribution, you will find that the outermost electron in aluminium is in a 3p, while the outermost electron that we're trying to remove from magnesium is in a 3s. So the basic difference between aluminium and magnesium is that the electron in aluminium is in a 3p, which is higher energy, further away from the nucleus, less strongly attracted to the nucleus, so easier to remove, needs less energy to be removed. Okay? Describe the bonding in a metal, any metal. Here he's saying aluminium. Well, the bonding in any metal is strong attraction. We could say strong electrostatic attraction forces between what and what? If we're talking about a metal, it is strong attraction forces between positive ions and delocalized negative electrons, or delocalized free moving electrons. So in a metal, the attraction is between positive ions and free moving or delocalized electrons. Give 2 possible reasons why aluminium is used for overhead power cables. Remember that we said when we use aluminium for overhead cables, basically because it's a good conductor of electricity. Any metal is a good conductor of electricity because it has free moving delocalized electrons. A metal is ductile, so it can be drawn to wires. Why do we specifically use aluminium? You can see because aluminium compared to the other metals has lower density, and the fact that it has a protective oxide layer, so it is more resistant to corrosion. Any 2 of these would be correct answers. Okay. Here he's saying uses for waste aluminum cans are being investigated. He says aluminum nanoparticles react with water to produce aluminum oxide and hydrogen. Complete the following equation and state symbols are not required. So you should realize that, first of all, he said that aluminum reacts with water to produce what? Produce aluminium oxide and hydrogen. So all we need to write is, how do we write aluminium oxide? It's Al2O3. The valency of aluminium is 3, valency of oxygen is 2, plus hydrogen. Hydrogen is diatomic, so it has to be written as H2, and then you balance. You need 2 of the aluminium, 3 water, 3 in front of the hydrogen. That's the balancing of the equation. Give 2 possible reasons for producing hydrogen from aluminium rather than from fossil fuels. Remember that we said we can produce hydrogen by cracking of alkanes that are produced from fossil fuels. He's saying if I produce hydrogen from aluminium, it is much better. Now, why would it be much better? Remember, if we're producing it in this way, no carbon dioxide is produced, so we do not affect the global warming or greenhouse effect, and the fact that fossil fuel is non-renewable while aluminium can be recycled. So these would be reasons for using this equation. Okay, the next question is about alkanes and alkenes, and he says describe how a sample of an alkane can be obtained from a mixture of alkanes. Remember, a mixture of alkanes, that means they are a mixture of liquids. It's obtained from crude oil. I can liquefy them and I can do fractional distillation. So the mixture is heated, vaporized, cooled, condensed at different boiling points. Now, the next question says complete the equation, state symbols are not required. So if I have octadecane, that is the C18H38, he's saying it will be cracked to produce what? Butene and one other product. So if I'm removing from the C18, I'm removing two C4s. That means I'm removing C8, then the rest will have C10. The H38, I'm removing 2 times 8, that's 16, so I'm left with H22. Okay, one of the products of this cracking reaction is but1-ene. Give the skeletal formula for 3 other alkene isomers of C4H8. So he's telling me to write the isomers of C4H8 and they have to be in a skeletal form. So you should realize that you can have the trans or the cis of but2-ene. And the third one is the one where we have a methyl group in the middle, so that would be 2-methyl propene. It still has C4H8. Okay, a question that says some reactions of but1-ene are shown. Give the name and structural formula of each of the products. Now let's look at this one by one. So the first arrow is from but1-ene reacting with Cl2 to give product 1. So he wants the name of product 1 and the formula of product 1. Remember that he wants it in structural formula. So please don't write it in skeletal or in displayed. He wants the structural form. Now, if I have an alkene and I react it with Cl2, what happens is the double bond opens up and I put a chlorine on both ends of the double bond. So this is my product in structural form. Now, what would be the name of this? This is 1,2-dichlorobutane. Again, remember that we count from the side that gives the lower number. Okay, the next arrow is the butene with hydrogen in presence of nickel. Now, remember that when we react with hydrogen in presence of nickel, you add hydrogen to the 2 carbons that had the double bond. So this is what you end up with, and this is actually butane. Okay, if you have the alkene and you put acidified potassium manganate, remember what happens is double bond opens up and you put an OH on each carbon. So you get what we call a diol with 2 OHs, and this is called butane 1,2-diol. If I have the alkene and I add steam, presence of H plus, the steam means I'm going to open up the double bond, put an H and an OH. Remember that this is added according to Markovnikov's rule. So the major product you would have is the one in which the OH is a secondary alcohol. So the OH is inside. So this is butane 2-ol. Draw the displayed formula of polybut1-ene. Again, you have to be able to draw the products of polymerization of but1-ene, and he wants 2 repeat units, and he wants it in displayed formula. Please notice what he's asking for in the question. This is the displayed formula for the polymer of but1-ene with 2 repeat units. State one advantage and one disadvantage of using incineration. You know that incineration means burning of the for the disposal of polymers other than the effect on climate. So if I burn the polymers, the advantage would be I am producing energy that can be used to generate electricity. The disadvantage is that they produce toxic gases. Do not mention producing carbon dioxide that causes global warming, because he says other than the effect on climate. In this equation, he gives me the complete combustion of butane, and he says 35 centimeter cubed of butane is completely burned in 300 centimeter cubed of oxygen. Calculate the final total volume of gas. Now, again, remember that we can relate directly in the equation the volumes of gases, not liquids, but the volumes of gases. So if he says I have 35 centimeter cubed of C4H10, now, how much oxygen do we need? According to the equation, 2 of C4H10 needs 13 of O2. So the 35 will need how much? 35 times 13 over 2. So we actually need 227.5 of oxygen. Now, how much CO2 will I release? CO2 2 gives 8, so 35 will give how much? So 35 times 8 over 2. So I will be producing 140 centimeter cubed of CO2. Then he added how much of oxygen? He added 300. I need only 227.5, and that means I have 72.5 centimeter cubes of oxygen left. And that means overall, the total amount of gas that is formed at the end of the reaction is the remaining of the oxygen that was not used, so the 72.5, plus the 140 that was of CO2 that was produced in the reaction. So this is the total volume of gas that is produced. Okay, last question. Explain the main hazard when using butane as a fuel in a portable heater in an enclosed space. Remember, enclosed space means lack of oxygen, and that means incomplete combustion, and that means carbon monoxide is produced, and the problem with that, or the hazard with that, is that it is toxic. Okay, thank you for listening to this video, and I hope it helped you to review what you need to know for the exam, and good luck.